Hello everyone. So for our research topic these past 2 weeks, I've been looking into R.D. Mohan's laboratory here at UMKC. He is a STEM faculty member and I just really liked his webpage when I first saw it. I noticed how he highlighted achievements of other UMKC students, how he talked about work that was being done by faculty members, and then the topic of his research focused on disease, which I was really interested in because I think diseases are fascinating, and as a pre-med student, of course, I'm interested in diseases and healthcare. So I looked into it. The main form of disease that he focused on was neurodegenerative disease and diseases of aging, and I thought this was really relevant to what's happening in healthcare now. We've kind of seen a shift in how a lot of the people that are being treated in hospitals are of later generations. They are aging populations, and therefore they're coming in with age-related diseases in a lot of cases, and neurodegenerative diseases like Alzheimer's, Parkinson's, prion disease, motor neuron disease. These are all things that we see older patients experiencing. So with that trend and more people having these diseases, and then of course medicine and researchers are always wanting to better understand disease and find new treatments, I thought it made perfect sense, and I thought it was really interesting how Mohan was focusing on these kinds of diseases and their mechanisms. So Mohan focused on a couple different things. One of them was SAGA, which is a chromatin modifying complex, and dysfunction in this complex has been linked to carcinogenesis and neurodegenerative disease. So that's one example. Ataxin 7 is a subunit of the SAGA complex, and it is subject to polyglutamine expansion at the amino terminus, and it can cause spinocerebellar ataxia type 7, which is a progressive retinal and neurodegenerative disease. So here's another example of something that can lead to a neurodegenerative disease. And then we also have a linkage between overexpression in ataxin 7 with ADHD. So it's not just neurodegenerative disease that ataxin 7 affects, it can also affect people by potentially increasing the risk of ADHD, and with poly-Q expansion of ataxin 7, we see patients with a higher body mass index, so that's another potential health concern that is produced by a manipulation mutation of ataxin 7. And then one of the other things that Mohan focused on was cytosine adenine guanine triplet expansion, and this results in poly-Q expansion at the amino terminus of ataxin protein 7, which can cause a fatal retinal and neurodegenerative disease that I mentioned earlier, the spinocerebellar ataxia type 7. So these are just some examples of complications that can result from manipulation or mutations of these DNA mechanisms, of these complexes, of the things that his research mentioned. Of course, there's a lot that goes into these diseases and this topic, and even these specific complexes and mechanisms that I mentioned, but the amount of research that I did briefly touched on all these things, and I haven't learned too much about this in my biology class yet, but it definitely was interesting to try to tackle a little bit, and I definitely did learn from it. So I enjoyed researching this, even if at times I didn't exactly know what it was talking about. I really did have a good time with this. So thanks for listening, and I hope you guys enjoyed your research too.